Hello and welcome to the cockpit of a Convair B-36 Peacemaker, which was a high-altitude long-range bomber designed towards the end of World War II. Now the fear was that Germany was going to invade the United Kingdom, therefore the Americans would need a bomber that could fly from the US over to Europe, drop bombs and then fly back to the US on a single tank of gas. But this didn't enter production until the war had finished, so then it took on a role as the main nuclear deterrent against the Soviet Union during the Cold War, and in this video I'm going to take you on a detailed tour of it. First we'll walk around the outside and I'll point out what makes it unique and interesting, and then we'll crawl back in here and have a look at the interior. So let's get into it. I'm Paul Stewart and I make videos about planes and some rockets. This includes reviews on board flights from around the world and guided tours through aircraft in museums. If you're into these types of videos, then please check out my channel and subscribe. And a massive thanks to the Strategic Air Command and Aerospace Museum near Omaha in Nebraska for letting me film this aircraft. It's an incredible museum and well worth visiting if you're in the area. As always, we'll start with the nose. Now it's not on this aircraft, but directly in front were two 20mm nose cannons. This wasn't in the original design. In fact, there was also no bubble canopy, as you can see here with the prototype B-36, and it wasn't until the cannons were installed that they had to raise the whole cockpit, as you see in this one, because it just wasn't enough space. Here's a photo of a production B-36 with the cannons installed. This flat oval shape in the greenhouse was originally there for the Norden bomb sight, and that required flat glass as to avoid interference with the calculations, but they later changed to a periscopic bomb sight that protruded through a hole in the glass. This glass oval was then replaced with a lighter metal. This here is a forward escape hatch for the forward crew members, although they'd need to feather engine number 3 as to avoid potentially hitting the spinning propeller just after you jumped. On the ground, they would access the cabin via stairs in the forward wheel well, and I'll show you there shortly. This blister back there was the port sighting station, and while not visible here, two remotely controlled retractable 20mm cannon turrets would fold up out of there. There's also two turrets above and below the fuselage at the rear, and another turret at the back for a total of 8 turrets of 2 cannons each, and I'll show you those as we walk around. The vibrations from the recoil were so dramatic that they could cause the electrics to malfunction. In fact, that problem was associated with a B-36B crash in 1950. This is the forward landing gear, which was steerable from the cockpit. Now that seems obvious, but the B-29 Superfortress had a castering nose wheel, which means that there's no steering wheel or lever, and the turning happens through differential braking and throttle input. And behind this was the radar antenna housing used for both the navigation and the radar guided bombing. Now let's have a look at the 4 bomb bays, which are massive. Well, actually, first, let's look at the incredible Mark 17 bomb, which was the first operational USAF thermonuclear weapon, or a H-bomb, with a H referring to hydrogen. It weighed 41,400 pounds, and the pilots actually reported the plane suddenly rising several hundred feet immediately after the bomb was released due to the reduced weight. In 1957, one of these was accidentally dropped over New Mexico, but thankfully the plutonium pits were not installed, therefore it didn't initiate a thermonuclear reaction. Back to the B-36, and you can see a circular door which we'll look through from the inside, and on the port side is a long tunnel connecting the 2 pressurized sections, and I'll crawl through that later. The yellow cylinders are all crew oxygen for potentially very long flights. The bomb bays could carry up to 86,000 pounds or 39 tons, which is incredible when the dry weight of a B-17 Flying Fortress itself was only 36,000 pounds or 16 tons. Moving forward is an extra fuel tank, and then eventually we reach another bomb cradle. Considering how large this is, it's no surprise to hear that it could fit another plane in here. I'll mention it later in more detail, but one also carried a nuclear reactor, which is pretty unsettling, and was used to test the safety of nuclear propulsion. This here is one of only 2 ever built of the McDonnell XF-85 Goblins. The idea was that this would be launched when a Soviet interceptor approached and fight them off while protecting the mothership. These would then connect via a large hook that you can see here, and the pilot climbed back onto the B-36. but its performance was inferior to any interceptor of that era, and the docking process was difficult and dangerous, so they cancelled the program. During their FICON project, which stood for Fighter Conveyor, here a modified Republic F-84 fighter, which unlike the Goblin was an established aircraft in itself, was used with the idea initially being that it would drop the tactical nuclear bomb, but later it was changed to a reconnaissance role. The modified RF-84K Thunderflash came with a big hook and an anhedral tailplane to help it fit inside the bomb bay. The idea was that these would quietly and quickly fly over highly defended targets, obtain the information, and then return to the mothership that would be sitting outside the range of the enemy defences. But hookups with the mothership were difficult, and the arrival of the Lockheed U-2 recon plane resulted in the program being cancelled in 1956. Now we'll move on to the landing gear, which was initially massive. Here's one of the two main landing gears, which are set up in a tricycle layout, and unlike many other aircraft of that era, it folds up into the wing rather than the engine cowling, and that's because the wing is just so big. Interestingly, the prototype actually came with these huge single wheels, which I've tried to film including myself to give you some perspective. They were almost 3 meters tall and weighed 1,300 pounds or 600 kilograms. They're the biggest tyres ever fitted to an aircraft, and because they put so much pressure onto a small contact point with the tarmac, the aircraft was limited to only 3 airports in the world, otherwise it would destroy the runways. In fact, they actually considered a tracked gear to spread the load further, but the idea was canned as too complicated. Moving on, we'll check out the wing and engines, which were massive. This was designed before in-flight refueling, so the wing had to be able to store a huge amount of fuel. An absolute priority with this aircraft was high altitude efficiency, therefore having the engines behind the wing avoided having the prop turbulence interfering with the airflow over the wing. The leading edge was also very thick because of the fuel tanks, so forward-facing props would be pushing directly back into that thick leading edge, thus reducing the efficiency. And because of the leading edge swept design, the propellers would also become dangerously close to the wing tip itself, and while they wouldn't touch it, it would disturb the airflow. So all of these problems were resolved by installing the prop engines in a pusher configuration. But having the 28-cylinder Pratt & Whitney R4360 Major Wasp radial engines backwards did lead to further problems. The engine was designed to sit in front of the wing, with the carburetor being kept warm by the air rushing past the engine and heating up. But when it was sitting in the opposite direction, the carburetor was now in front of the engine, so the intake air was cold and humid. Ice would build up and obstruct the air intake, which would gradually increase the richness of the air-fuel mixture until the unburned fuel would make its way through into the exhaust and caught fire. Now, due to the engine fires, engineers would joke that the aircraft slogan became 2 turning, 2 burning, 2 smoking, 2 choking, and 2 more unaccounted for. You can see these little squares in the props. Warm exhaust air was pumped inside the hollow propellers and would exit via here, and this helped avoid icing. Remember that this could climb up to 50,000 feet, and unlike other high-altitude aircraft like the SR-71, there was certainly no aerodynamic heating with this. With the B-36D model, 2 General Electric J4719 turbojet engines were added to each end of both wings, and they were retrofitted to older models. So it ended up having 10 engines, leading to the slogan 6 turning and 4 burning. These significantly improved takeoff performance as well as the quick dash over to the target, but otherwise they were usually shut down during cruising to save fuel. These louvers you can see here closed the airflow off at the front as to reduce drag when they were turned off. In total, all 10 engines could provide 40,000 horsepower for brief periods of time. Usually jet engines use kerosene-based fuels, but to reduce complexity, this was designed to run on the exact same fuel as the piston engines. Now, because of this, the jets probably weren't quite as powerful as they otherwise could have been, but the trade-off was worth it to avoid having separate tanks and lines. These turbojets were shared with the B-48 Stratojet, which used 6 of them, and the F-86 Sabre, who had 1 of them, so it was very versatile. And here we are at the very wingtip. With a wingspan of 70 meters or 230 feet, it's wider than a Boeing 747-8 or a C-5 Galaxy, which is incredible considering that this was designed in the 1940s. You'll notice that the 3 individual single-slotted flap segments on the wing's trailing edge between the engines have all been lowered to dramatically improve low-speed lift. They look ungainly but are extremely effective. By the way, those 3-bladed propellers were 19 feet or 5.8 meters in diameter, making them the second largest diameter props ever used in a piston engine aircraft after the German Linke Hoffmann R2. On top around this position and underneath too, there were 2 more retractable and remotely controlled 20mm cannons, controlled remotely from inside. This circular transparent bubble was used as a sighting station for the gunner, and here's the ventral entry hatch, which we will climb into afterwards. Now let's check out this tail, and what's interesting is that they initially considered a twin tail design, similar to the B-24 Liberator, as that design had a number of advantages. Remember that this was designed in the 1940s when buildings just weren't as massive as they are now, so by using twin and even triple tails, you could spread the same lateral control surface over multiple tails instead of having a single large one. These are some of the reasons why the Lockheed Constellation and the Lancaster bomber had twin or triple tails. But in the end, they went with a single large tail and saved 3,800 pounds or 1,750 kilograms, but needed extra large hangars. Right here at the back are more cannons, which were remotely controlled. Above is the ray dome, and inside that were 2 radars which would detect enemy aircraft and guide the firing. Now everything in this aircraft is massive. In fact, the control surfaces, such as the rudder and elevators etc., had the same combined surface area as the B-24 Liberator's entire wing, but they did not have hydraulic support to move. In fact, they worked by the pilots only moving small servo tabs, which were like trim tabs, in the opposite direction, and then the air would move the whole control surface in the direction they wanted. It's really quite an ingenious design, as it avoided the need for heavy hydraulic systems, because again with this aircraft, a priority was increasing fuel and bomb load. Moving back along the starboard side, and we have another sighting station. Now, if it didn't have nukes or fighters in the bomb bay, it also carried ECM equipment, which stands for electronic countermeasures. These are probably some of the best defenses these bombers have, and some of the equipment remains classified to this day, but essentially it's designed to confuse enemy radar and missiles. It can detect enemy radar waves and return a flood of waves to overwhelm their receivers, or it can even send back incorrect information so the aircraft appears many miles away from where it actually is. It had a crew of 15 consisting of a pilot, co-pilot, 2 navigators, a bombardier, flight engineer, radio operator, radar operator, 2 ECM operators and 5 gunners, but more crew were used in the reconnaissance version. This specific aircraft is a B-36J and built as a featherweight, as the role was now primarily reconnaissance. To improve performance, all of the guns except for the tail were removed, the blisters were replaced with flat windows, and the crew numbers were reduced. The reduced weight allowed a surface ceiling of 48,000 feet, although there's many reports of these going well above 50,000 feet. First, we'll enter the pressurized forward section, and I'll show you the tunnel and rear sections later. We'll enter via the forward wheel well using a retractable ladder and attempt to climb up while holding a camera and a light. To help orientate yourself, we're standing directly under the flight deck, which I'll show you shortly. Straight ahead is the radar bombardier station. The B-36 was nicknamed the Peacemaker, which came from a company-wide naming competition. The idea was that it made peace by being a deterrent to any military aggression. But there were objections from religious groups who felt that they already owned that term, so officially it was just called the Convair B-36. Then moving forward, with an incredible but probably quite unsettling view at 40,000 feet, is the navigator station. Obviously in the era before GPS, and the original plan for this to fly across the Atlantic Ocean, this guy's job was extremely important. Spinning around, and you'll notice these green first aid kits hanging from the walls. These always needed to be in arm's reach to quickly cover a wound if, for example, a crew member was injured by a bullet or shrapnel from a Soviet interceptor. The round hole is the forward cabin escape hatch we saw from the outside before, with the door removed so that museum visitors can see inside. Then we step up and over into where the radio operator sits. Up here is the port sighting station, as there were two retractable 20mm cannon turrets up there. Moving back down here, and you got a brief glimpse of it just before, is the communication tunnel connecting the pressurised fore and aft sections. Here I am from inside the tunnel, inside the B-36. It's about 85 foot long and about 2 foot wide. It's certainly not the most comfortable way to travel, really highlighting how brave people were back in that era. And here I am actually just coming past a window, which is hard to see. What is that? I think that is the bum hold. So it's certainly an interesting way to fly, but I think I'll take an A380, thanks. The crew would lie on a railed cart and propel themselves along using the rope hanging from the roof. There was a wire connected to the cart so that it could be summoned from either end of the tunnel by a crew member. This red and white lever was the hydraulic pump and used to drop the main landing gear manually. Moving back past the radio operator's seat, who, by the way, was sitting facing towards the rear if you're disorientated, and above them is equipment which is sitting on dampeners to help absorb the vibrations generated by those 6 radial piston engines and potentially the guns. And that large circular hole was the starboard sighting station, which would have been like a bubble as to improve their visibility, as they could stick their head partially out of it. The first hatch down here is the access hatch for maintenance, although in flight the crew could crawl through here and gain access to the wings. In fact, here's the flight manual and an explanation of how to release the main gears manually, and it includes a crawlway just above the folded landing gear, as you can see here. They provided a warning to be careful for obvious reasons. And below that is a hatch into the bomb bay itself. So here you could conceivably manually release bombs if they got stuck, and this is how one of those parasite fighter pilots would get down into the aircraft. There's more equipment, and we'll start making our way back forward and up to the flight deck. Unsurprisingly, considering how large this plane was, it was fairly easy to move around. I filmed the B-46 cockpit the same day, and that's a very different story, so check out that video as well. The view up here is pretty incredible. In fact, it somewhat reminds me of the Hughes H-4 Hercules at the Evergreen Museum in Oregon. I should mention that the flight engineer's seat has been removed so that the museum visitors can fit in. This guy's job would have been one of the busiest, monitoring the 10 engines, fuel load, oils and electricity. Remember that one of the primary aims with the B-36 was a long range, so it had to carry a lot of fuel, and to maintain the centre of gravity, the flight engineer would need to ensure that it was all being burnt evenly from the different tanks. They had 6 duplicate throttles here for the piston engines, but interestingly, the jet throttles are only accessible to the pilots and positioned just above the pilot in command, although admittedly the engineer could probably still reach these if they had to. Let's keep looking at the 2 pilot seats, with the pilot in command on the left and the co-pilot on the right as usual. There's a massive nose wheel steering control, and in front of the pilot were the usual dials, although what's interesting is that in the centre, where you would usually have information about each engine, but with 10 of them, there's simply not enough room, so they have just the 4 turbojets, and remember that their 4 throttles was just above the pilot. You may recall that the 6 piston engine dials are displayed on the flight engineer panel just behind them, and they also have duplicated throttles for those as well, but just not the jet throttles. In the centre are the 6 throttles for the piston engines, and the usual trim controls, and even a Honeywell autopilot system. I'm sure that the flight engineers would joke that the turbojets were simple enough for the pilots to manage, but the complex piston engines, well, they needed far closer attention, hence why that job was theirs. On the starboard side is the co-pilot's yoke and more dials and controls. Up above you was the Astrodome and observation hatch, which provided for a brilliant view of the top of the aircraft. Just quickly, if you enjoy these videos, then please consider giving it a thumbs up and or joining the channel as a supporter. These cost a lot of time and money to make, especially when I'm flying from Australia, and I'm keen to avoid product placement where I'm paid to tell you I love a product. The join button is below, and back to the video. And heading back down to the footwell, we'll exit the aircraft and walk to the rear. The Recon RB-36 had a pressurised and manned module with 14 cameras in the forward bomb bay, up to 80 photo flash bombs in the second bay, an additional fuel tank as you see on this one, and more electronic equipment. They now had a crew up to 22 to take and process all of the imagery. The B-36 was also used for research into nuclear aircraft propulsion. In fact, a heavily modified NB-36H was built and carried a single megawatt 16-ton nuclear reactor in the bomb bay. An 11-ton crew compartment protected by rubber and lead was installed up front. The nuclear reactor wasn't used to propel the aircraft, and the research was mostly looking at potential harm to the crew and environment from the radiation. But Air Force priorities were elsewhere and the program was cancelled. Now, through the magic of editing trickery, some stairs will appear and will climb up the aft cabin entrance hatch. Now, an alternative would have been to go through the entire communication tunnel from the forward section. Looking straight ahead is the tail gunner's position with the remote controls. As they did with the B-29 Superfortress, it's much easier to manage the pressurization if they can centralize all the crew, including the gunner's positions, as opposed to having another pressurized position right at the end of the fuselage. As you can guess seeing the toilet paper, this was the toilet, which didn't have a great deal of privacy, although I'm sure neither crew wanted to look at each other during such a delicate personal time, and I'm sure the air cleared quickly as well. Well, hopefully. There's a smaller urinal above it as well. This whole wall is the rear pressure bulkhead, but there's a door here where you can crawl out to the guns, but this is just for maintenance on the ground, and it was obviously unpressurized and very cold during the flight. Moving around, and we have the galley, well, a small oven. While this does look like an afterthought, the museum staff assure me that it's genuine and they have it in old photos. While pilot comfort back then wasn't a priority, considering how long the flights might have been, some sustenance was important. There's the hatch I came up through just then, and the ladder has disappeared, and here is the lateral ventral sighting station and the lateral gunner's seat. On the underside, there were two more retractable 20mm cannons. When not shooting, he would have had an amazing view of that wing and engines. Up here in the centre are multiple bunk beds, as this was designed again to fly non-stop from the USA to Europe and return, so crew rest was important. Again, you can get a view of the whole aft section, and it really is quite spacious when compared with most other military aircraft from that era. And then stepping back past the lateral gunner's seat again, and you can see the other end of the communication tunnel. To save weight, therefore focusing on increased fuel capacity and range, they used magnesium skin on certain parts of the plane, leading to the nickname the magnesium overcast. But it was found to be highly flammable, as any chemistry student knows, and used far less now. Walking back past the cooker and bunk beds, and we'll see the starboard sighting station and the gunner's seat, and again another door into the space between the bomb bay and the wall. One thing I didn't film well here, and we'll jump back to some older footage, is the upper gunner's sighting platform. There will be someone sitting above this green platform and looking through a transparent dome, while operating more retractable cannons on top. Here's an image from the manual, and there's that green platform again. Here's what the lower gunner's position would look like as well. A total of 384 Peacemakers were built between 1946 and 1954, but in the end they simply couldn't compete with the faster and also capable of in-flight refueling, jet-powered B-52 and the B-47. And here I am walking back down the stairs of this incredible machine. It's worth mentioning two other aircraft based off this one. First being the YB-60, which had a swept wing design, and all of the piston engines were removed and replaced by 8 J-57 turbojets. Now, while it was cheaper because it was based off an already established aircraft and had a bigger bomb load, it ultimately lost the contract to the Boeing B-52, and only one was ever built. There was also a passenger version, well, for the military, called the XC-99. Here's a photo of it with the B-36, and you can see the tail and wings are the same, but the fuselage has been considerably enlarged. It had a double deck and capable of carrying up to 400 soldiers, or 100,000 pounds or 45,000 kilograms of cargo. A civil version, the Model 37, was planned but never came to fruition. While only one was ever built, it served with the USAF for 8 years, carrying personnel and cargo. If you enjoyed this video, then please give it a thumbs up and check out my channel for many more similar videos I've filmed here at the brilliant Strategic Air Command and Aerospace Museum. Thanks for watching.